Hi, these materials are posted on Google Classroom and were given out in class. If this is a later term than September of 25, this is probably already a part of your packet. So you might have seen something with the letter E or noticed this scriptish E on your calculator. And that E is in some ways similar to pi because it is an irrational number. So irrational meaning that it can't be written as a simple fraction. The decimals would keep going. It doesn't repeat. It may look a little bit like it repeats to a certain point on your calculator, but it doesn't actually continue the same pattern. And so when we look at that, we're just gonna, in general, we can use an approximation, but the calculator will give us exact figures. So we're gonna be using that button on the calculator, not typing in this number, but this is an approximate value, 2.718 or 2 and 718 thousandths. It is also called Euler's number. You don't have to memorize that, but that's also just a name for it. And it is used in some real world scenarios. For instance, we've already been doing some things with population, but with population, radioactive decay, and it is when you see something called continuous compounding. So you might be given the formula to use for the population or the radioactive decay, and it may have E in it, or if it says continuous compounding, then that means we use a different formula than our usual, and that formula is going to be that the final amount is equal to the principal times E, and then R and T are actually in the exponent. So that's not really going to come up in these problems, but you are going to want that. And so exponential functions that have a base of E are called natural base exponential functions. Not nature base, natural base. And so an example, we might write f of x or y is equal to e to the x. So the x, it's still an exponential because there's still an x in the exponent, but the base is e. When we do base e logarithms, they have a special name. They are called natural logs or natural logarithms. But usually we just see natural log. And so instead of writing, not that this is wrong, but you usually would not see it, instead of writing log base e of x, we would write ln of x. So when we write ln, which we read typically as natural log, when we write that natural log, ln means natural log, when we write that, and you'll recognize there is a button on the calculator, a lot of times you'll see that I will write that. I will often write the ln, the L in cursive, because otherwise sometimes people think that it says IN or something. But you'll see that on your calculator, that natural log of x. And then we don't need to write that the base is e, because if we use natural log, it's understood that the base is e. Also, there's a special button for that, and then we don't have to do change of base because there's a special button for that. So we can convert between log form and exponential form, just like we could with our other logarithms. The guy who is by himself is our argument. We know we've got our exponent, so instead of writing log, we're going to write ln, and then the 24, the argument, and then equals the exponent. So ln of x equals 9. The exponent is the one on the side by itself when it's in log form. So then here, natural log of 72 is equal to x plus 5. And we don't actually have to write the base because it is understood to be e if we are using natural log. So now we're going to go back the other direction, and we're going to write these back in exponential form. So the base, if it starts out with natural log, we know the base is e. The exponent, remember, is the one over there by himself, and it equals the argument. So e to the x power is equal to 6. E to the 32nd power is equal to x minus 9. And you could write x minus 9 equals e to the 32nd. I mean, the sides of the equation don't matter. We can also condense. So remember, just like before, plus goes with multiply, so 3 times 16, so natural log of 48. Since it's just one number, even though it does have 2 digits, you would not have to have the parentheses. If there is a number in front, remember that that number is an exponent over here. So this is really natural log of 3 squared, which would be 9. And then remember that minus is division when we condense. So this is 63 over 9, which is natural log of 7. Now, we can get number answers. They will be, we'll have to round them. They'll have decimals. But we can get number answers. But in this case, it just says condense. It doesn't say condense and evaluate. So you don't need to grab the calculator. I mean, unless you need it for 63 divided by 9. Or you might need the calculator or want the calculator here because we have natural log of 64 to the 1/3 power. And then we have plus natural log of x squared. So you can put 64 to the power inside parentheses, 1 divided by 3, and then you will actually get 4 in case you didn't already know that is 4. And then to finish condensing this, we need to put those together, and they are being multiplied. So remember, addition goes with multiplication, and slide it into some parentheses so that we know that we're taking the natural log of not only the 4, but the 4x squared. So now we're going to go the opposite direction. We were condensing. Notice our final answers were shorter. Now we're going to expand, so our final answers are going to get longer. And even though it says log on the bottom of your reference sheet, it should still be helpful here. So natural log of 5 plus the natural log of x. That's it. If there is an exponent, more than one way you could handle this, but I would suggest get rid of that extra exponent by multiplying these. So I've got a to the 6th over b to the 2nd. And then remember, each one, if it starts out with an exponent, you're going to end up putting it in the front. So 6 natural log of a and 2 natural log of b, and then they are being divided, so there is a minus in the middle. In number 12, we get to use what we know about radicals and changing radicals into fractional exponents. So this is the same as if I wrote m to the 2 over 3, so the power stays up top, the root becomes the bottom, n to the 1 over 3. And now we're going to expand that, so they're each going to get their own natural log, and exponents will come to the front. So natural log 2/3 the natural log of m, plus, because it's multiplication, 1/3 the natural log of n, both with their own natural log. So 1 through 12 is those are good examples for 1 through 12 on the homework page. So skip over the page that says the solving equations. You could work on the homework page, similar to these first ones. Pause me, try that, and come back. And then I'm going to continue the video with some examples for solving the equations, which have some varied types. All right, welcome back. I hope that you were successful on that other page, or maybe you're just trying to get all the notes at once. Either way, welcome back. So very much like when we had regular log with a base or common log, if each side has only one log, then we can drop the logs and solve the equation. So the logs here, the natural logs, can also get dropped, and then it is just a matter of solving this equation. So you may have the same number of steps I had, or you may have taken an extra step or so to get that, but 7. And then notice it does say check for extraneous solutions. In this case, what that means is, remember that the argument, right, the part in here that you're taking the log of, the natural log of, must be greater than 0. So 0 is not okay, and negative numbers are not okay. In this case, if I plug in 7 in both arguments, I get 1. So 7 is good. We can keep it. It is not extraneous. So don't forget, numbers in the front. So if necessary, we might need to condense. So in this case, we're going to condense, which includes replacing that squared. Then we're going to drop the logs. And because we have a squared, everybody needs to come to the same side, of course, because we're going to factor and solve. And even though it later gets the squared, in the original problem, right here, that k, so that, because of that, oops, sorry about that, this one extraneous, so only keep the 5. So this time we need to condense on both sides. When I condense, I've got 72 over 4, and over here, I'm going to have 6 times a minus 2. And then drop the logs. That's 18 is equal to distribute, and then finish solving. I think this one comes out to be 5. 5 minus 2, still positive, still good. Here, 2 in front becomes an exponent. So natural log of m plus 4 squared. Now there's only one natural log on each side. Gone. Please remember that when you do m plus 4 squared, it does include m squared. It does include 16, but you have that 8m, I call that a double combo, in the middle. Because remember that this means m plus 4, m plus 4. So when we do all the distributing, we would end up with 8m in the middle. So subtract 4. Now we're going to, what multiplies to be 12 and adds up to be 8. Six and 2. So we get -6, -2. -2 is cool. -2 plus 4 is 2, but -6 plus 4 is a negative number. No. So again, one of them goes. 13 through 16 are pretty similar to 13 through 16 on the homework. They are not exactly alike, but they are similar enough to be a good example. Now, things switch gears a bit in the next part. So this part, we had logs on both sides. We condense, we drop the logs, we solve depending on what kind of equation it is. Right? We had to factor if we had a squared. We did not have to factor if we had a linear equation. Now we do not have logs on both sides. So for 17 and 18, there is only one side has ln. It might have two of them, but it's only on one side. When that happens, we're going to change this to exponential form. So, what is the base? The base is e, remember? So then this is e to the second power is equal to 8x. Then we're going to divide by 8 because we're trying to get x by itself. And then this would be an exact answer, e squared divided by 8. Okay, that is the exact answer. Kind of like leaving something with pi in it is exact. If we want to have an exponential, we want to have something with an exponent. Sorry, I'm not sure what I did with my other paper. And I did not grab a calculator. So if we want to not have an exponent, if we want to have a decimal approximation, then at this point we need to grab the calculator and we will have to type it in. And to get E, you do second and the ln button. It's going to look more like in on there. Second and the ln, and then what you're going to get, it's going to go E to the, and it gives you a parenthesis. You're going to put the 2 inside and then close it and then divide by 8. And then you're going to round that to however many decimal places you're asked. In today's class, I just asked that they round it to 2 decimal places. But please know that it could be 3 places, it could be 4 places, depending on the situation. Okay? So if there are 2 natural logs on the same side, you might say, well, I could just move one over. Well, you could, but it's not really going to help because that 7 is over there and he doesn't have a natural log. So you're going to condense first. Now we're going to go to exponential. So e to the 7th power is equal to x over 9. Now we're going to get the x by itself, so we would multiply by 9, right, to get rid of that. So doing 9 times e to the 7th, or e to the 7th times 9. And again, grab your calculator. So we have exact answers. We would say in terms of e, they still have the e in them. And then we have an approximate, where we keep a couple decimal places, or 3 or 4, however many. Now number 19 already has an e, right? So 19 already has an e. So now we have a variable in the exponent. And the base is e. And we have a variable in the exponent. When that happens, we're going to do natural log of both sides. And then I'll show you what happens there. So I'm going to go natural log of e to the x equals natural log of 57. So think about that natural log means log base e. So if the base and this argument are the same, they basically get rid of each other. And this just becomes x. Just like if I wrote log base 2 of 2 to the 3rd, well, because it's base 2 and this is 2, it's just 3rd. Or if it was just log base 2 of 2, it would be 1, like that's first power and it's equal to 1. So when you have ln and e together, they just get rid of each other, and then the exponent can come down into the equation. But on the other side, it didn't have an e. So then you would grab your calculator and do natural log of 57. And there's actually a button for that. You don't use the second. Just natural log 57 equal. Sometimes it's going to have a little more steps than that. If you have to do this, you also need to be sure you isolate e first. So we need to get this baby by himself. So we're going to get rid of this 6 by adding 6. And then e to the y plus 3 power is equal to 30. Now I have to get that variable expression out of the exponent. So now we're going to do ln on both sides, and you could even just like write it next to this, right? And then the ln and the e out of there, that's just equal to 1, and 1 times y plus 3 is just y plus 3. And then over here, ln of 30. But we need to know, we need to solve, so we need y. And to get y by itself, we're going to subtract 3. Now, be careful here because you cannot subtract the 3 from the 30. So the 30 is the argument for the log. So it's going to be like that. It's not the same as natural log of 27, so don't go there. And then that is just typed into the calculator, round it to the appropriate number of decimal places. All right. Let's go ahead and look at 22. By the way, if it turns out that it ends up with like a big fraction, that big fraction, I don't know if that's going to happen with what we're getting ready to do. The quote big fraction, you need to hit equal or you need to use extra set of parentheses. Okay, for something like 21, isolate the E. ln of both sides so that we bring it down. Bring that variable that's in the exponent down. And then we're going to need to divide by 4. So in the calculator, that's going to look like ln of 95, close it, divide by 4. If I don't close it, then it's going to give me natural log of, I don't know, like whatever number that is, 19.25 or something. Not what you want. Sometimes there's going to be 2 steps to isolate the log, or isolate the E. So I'm going to subtract the 3. I'm going to divide by 2. Now that the E is isolated, now I'm going to get rid of the E by doing natural log. It's going to bring that exponent down. And then I'm going to have to add the 9 outside. All right, thanks. That is what we went over today. And students did the homework page. If you were not here today to pick that up, if you look on Google Classroom, I have posted, it says natural log, exponential logs. Pages 1 and 2 of that were the notes, and pages 3 and 4 were the homework. There are some other things attached, but I believe they are things we've already worked on.